Hi everybody, this video is for those of you who were in class today and you took the vocabulary and key concept test. After that test, I asked you guys to please log on here, watch this video. There's one activity in chapter 2, lesson 2.3 that I would like you to do. So go ahead and log on to 2.3. And I would like you guys to please go to activity number 2. And you can pause this video until you get there. So in activity number 2, you're going to notice, here, let me open, this looks different than yours because I've got my instructions, but you're going to notice down at the bottom that there are 2 screens. I'd like you to go ahead and go to screen number 2, and you're going to see this kind of information. We're going to go into the sim, and we're going to try to change the number of births for the wee bugs. So I'm going to ask you to launch this, and you are going to have a split screen because you're going to need your curriculum on one side. You need to be able to toggle back and forth here, but you also have to listen to me. So whatever you need to do to make that work, okay? So if you open your sim, please make sure you're in the 3 populations mode. And we're just going to let this thing run. Just remember that I have showed you guys yesterday these little orange canisters, and they represent the ESMs for each one of these organisms. And we know that as the organisms just go through their everyday life, the number of ESMs decrease because they need energy in order to live their lives. And if they are reproducing, that energy depletes pretty quickly. So they have to eat in order to replenish those ESMs. That's not really what I want to show you today, though. I want you all to push this little overlay button here. And we've looked at this before, but I'd like to introduce a new word, a vocabulary word, and that is food web. This is a food web. And a food web is actually just a really simple way for us to identify the relationships between all the organisms in an environment. And specifically, we're trying to find out which is a consumer population, what is the resource population. So if I'm looking at this, let's say I'm going to focus on the wee bugs today, which we are. The wee bug is eaten by the furbills, and the wee bug eats the green leaf. So the green leaf is the resource population of the wee bug, and the furbill is the consumer population of the wee bug. I'd like you guys to really take notice of this orange arrow. The orange in this sim always is going to represent the ESMs. So why is this dotted line turning into an arrow that's pointing to the wee bugs? It's going from the green leaves to the wee bugs, and then again from the wee bugs to the furbills. Why is that? In a food web, we're being told the path that the ESMs, or the energy, is taking. So in other words, when the wee bugs eat the green leaves, the ESMs that are in the body of the green leaves go to the wee bugs. So the arrow is showing the path that the energy is taking, not pointing to what eats what. It is very important, and you will be asked about that, the direction of the arrow. So it's really, really important that you understand the direction of the arrow is showing the direction that the ESMs are taking. They're going, once again, from the resource population to the consumer population. We see that up here, where they go from the resource population, which is the wee bugs, to the consumer population, to the furbills. All right. So I'm going to go ahead and just get ready to reset. I'm not going to do that yet. I'm going to have you guys come back here to your curriculum. And let's find out what this activity, this challenge that we're going to take. So it says here, in the sim, students changed the size of the resource population and observed the effects on the births in a consumer population. What can change the number of births in a population? So in the sim, the wee bugs eat the green leaves. So here's a green leaf. This is another food web. The green leaves, the ESMs travel from the green leaves to the wee bugs, and that's why we see the arrow like that. So let's answer some questions here. It says wee bugs get energy storage molecules from eating green leaves. What changes to the green leaf population could increase the number of births in the wee bug population? Well, I hope you remember what we did yesterday when we added more sugar and gave more sugar to the yeast. Then that caused the yeast to reproduce more. So if we gave the wee bugs more of the resource population, then we can expect the wee bugs to have higher number of births. So let's go ahead and select that we're going to increase the green leaves. Let's review the steps below. What will we change? The independent variable in the test. Well, the independent variable is the one thing in an experiment that we change on purpose. Yesterday, we changed the amount of sugar that we gave the yeast. And so up here, we've already selected that we're going to increase the green leaves. So that's what we're going to type in here. Let's go ahead and increase the green leaves. We're going to increase the resource population. And then what will be observed and recorded? This is the dependent variable. The dependent variable will change depending on the independent variable. So the independent variable, one thing you can remember is the independent variable is what we change on purpose. The dependent variable is the data that we get as a result of this change. So we've already said we're trying to get the change the number of births in a population for the wee bugs. So that's what we're hoping to find. So what will be observed and recorded? The number of births in the wee bug population. Okay, let's just review very quickly what we're going to do here. You guys are going to launch your sim. We're going to run the sim for 20 time units. Then you're going to press pause. And I'm going to show you all of this. I'll do it with you. You guys follow along. Open the food web overlay. Make the change to the green leaf population that you predicted would increase the number of births in the wee bug population. And observe how the number of energy storage molecules in the green leaf population change when we make that change. So I'll explain that in a minute. And then we need to lock it, press play, and run the sim for another 20 seconds or another 20 more time units. And then we're going to analyze, and we're going to write some information here in a data chart. And then we're going to answer a couple questions, and then we'll be done. Okay? So let's go ahead, and we're going to launch this. So I'm going to reset it. And I'm going to let this run for 20 time units. So just let yours run. Get ready to hit pause. As soon as it hits 20, I'm going to pause it. Okay? Now, we need to change, first of all, take a look here. Here are this is my population of wee bugs right now, population of green leaves. I said I want to increase the green leaves. By increasing the resource population, I'm hoping that that will increase the number of births in the wee bugs. This is how we're going to do it. Come over here and click on this tab. And this gives me a chance to increase or decrease a population. In order for us to see the greatest results, like the most dramatic results, we're going to go ahead and crank that number of green leaves up as high as it'll go. So 300. And then this step is super important. I want you to lock the green leaf population. So that's going to stay at 300. Now in nature, that normally wouldn't happen. There's always going to be births and deaths. But we're locking this because we want to make sure that the wee bugs always have a surplus of a resource population. Okay? I'm not going to do anything to the wee bugs, and I'm not doing anything to the fur bills. And I'm going to go ahead and close that. And then we're going to let this play again for another 20 time units. So I want to let this run to 40. And so I'm just going to let that keep going. Just make some observations. I can see my wee bugs and my fur bills, and I'm at 40 now. So pause that. And then what we're going to do is we're going to analyze. So come over here and click Analyze. I've got two sets here that we're going to take a look at. And I'm going to use this, this range window to get some information, okay? Let's come back to the curriculum and answer some questions. So what we want to do is I want to see what were the number of wee bugs birthed during that 20 time unit range before the change. So when you come back here, take your little, you can grab it with your finger here, or you can grab it with your finger down here to the dot. But I want to stop it at 20 time units. Okay? And I'm going to adjust this just a wee bit here. Okay, there. All right, here's what I was looking for. I want to see when this change actually takes place. And so you're going to fudge it a little bit. I want you to manipulate it so that we see over here the number of wee births that were born, as well as the number that died during that first 20 time units. And I'm looking for a relatively stable population. So I'm looking for the same number of births and deaths. Try and get yours within that time. So your time should be 20, and you can kind of fudge it. So watch that you've got 20 time units here, but make it so that the change is 0. So I had 25 wee bugs born during that first 20 seconds or 20 time units. So I had, oh, I forgot. How many did I have? I had 25 born. So come over here in your first box, and then we're going to say we had 25 births. And then it wants us also to kind of pay attention to our ESMs. So during this time, I had 1,509 ESMs. And I'm going to put that down here below in parentheses. I had 1,509 ESMs. I'm going to double check. 1509. Yep, that's right. Now, the next little bit I need in my data table is what was my number of births and ESMs after the 20 time unit range. So I'm going to slide this. First of all, do you notice something? Look at this. When I increased my number of green leaves, that shot that population up to 300. And look at that perfectly straight line. That doesn't happen in nature. There were no deaths at all. No additional births and no additional deaths. And so that's why it's totally flatlined. Right here, we had a little bit of a dip, and then consistently over the next 20 time units, we had a pretty consistent increase. So I'm going to take my range and I'm going to move it right to where it says time unit is 40. And I always like to make it go just right at the very end. Okay. So now I'm going to look at my population is 202. Don't really care about that. I'm really focused on the births. Holy cow. During that 20 time unit range, we had 128 births. That's crazy. So come on back here. We're going to say we had 128 births. And let's see, we can expect the reason why we had so many births is because there was an increase in the ESMs. We had so many green leaves that were available. And we can see, sure enough, it was 2,777 ESMs. Now, this is mine. Your information might be a little bit different, and that's okay. Go ahead and put what you have. Okay? So I can see, just looking at my data, there definitely was an increase in births as well as an increase in ESMs. I want you to see that relationship, that correlation. Let's come down here and answer some questions then. Increasing or decreasing the green leaf population, what did we do? We increased it. So increasing the green leaf population led to what? more, fewer, or the same amount of energy storage molecules? We can see definitely there was more energy storage molecules in the greenleaf population. And after the change, the wee bug births definitely increased. Now, my dog is right by my computer, so if you hear weird breathing, that's my dog. She's decided to come visit us. All right, let's go ahead and use the range window to compare the number of births with deaths after the change. After the change. So we're going to come up here. We're not moving this at all. We're looking. And the number of births and deaths after, there definitely were more born than died. Okay, so we're going to come back here. After the change, there were more births than deaths in the wee bug population. And after the change, the wee bug population definitely increased. We had 202 population. So we can see that by increasing the ESMs, we've increased the population, the number of births in the wee bugs. I want you guys to go ahead, read, and answer this box. Explain why a change in the greenleaf population caused the wee bug population to change in size. Be sure to use these vocabulary words. Use births, deaths, and energy storage molecules in your answer. Go ahead and make a prediction here and then explain your answer. Once you're finished, make sure that you hit the hand in button, okay? And that's all I want you to do today. Thanks, you guys. Good work.